Hey everybody, we have a lot of material to cover, so we're just going to dive in. I'm Phil from Upbound, and I'm working on the Crossplane project, and I'm joined today by Sudhanva from Microsoft, who, among other things, is a contributor to the spec, which is a collaboration between Alibaba, Microsoft, and Upbound to build an open application model for Kubernetes and other platforms, which makes it easier to get your apps from dev laptop into production in a team environment in the smoothest way possible. So we're super excited to talk to you today about different approaches to modeling cloud-native apps, some of the limitations and trade-offs involved in different approaches, and some of the desirable properties you might look for in an app model. So what's in an app model? Typically, it starts off with an app dev creating some container images for the front end, the back end, microservices in an app, and then getting that into Kubernetes by defining some workloads, which are basically deployments, services, ingress config. And then you have a question of, do I want to run in-cluster stateful services, or do I want to use cloud services so I'm not getting a page at 3 a.m. for things like databases and caches and buckets? And then there's the configuration of the app, whether it be in environment variables or config maps or secrets to get access to the endpoints that your app needs to use. So then you take that in combination with the ops behavior. This can be like auto-scaling, ingress config, security groups, health monitoring, logging, all that kind of stuff. So that's really what goes into an application definition. And then you can take that content and package it up however you like using tools like Helm, which is great for bundling up a bunch of YAML and templating that. You can take a Helm template output and pipe it into Customize for customizing the configuration there. You can bundle that up again into a CNAP bundle. So lots of ways of packaging up the app model content. And then you'll deploy it via typically imperative pipelines, GitOps workflows, or even workload scheduling if you're using something like KubeFed V2 or similar projects to schedule an app onto one or more target application clusters. So what does it look like taking an app from the dev laptop into prod? Typically as an app dev, once I have my container images, I might reach for something like Docker Compose. And so that'll get me up and running on my local dev laptop pretty quickly. I'll probably be pulling in some in-cluster stateful services like Postgres or Redis. And I might even be able to sneak that onto my dev or test cluster, depending on the environment that I'm running in. But at a certain point, somebody's going to say, hey, look, we really should be running staging and prod looking very similar to each other. We want to use cloud services in prod. All this needs to be in Kubernetes. And so you'll typically have like an app ops person helping out to get all the deployments and the services and the package and the delivery and the deployment pipelines configured, gluing everything together, including the IAC tooling, whether you're using Terraform or CloudFormation or the cloud CLIs, and then basically getting all the cloud services provisioned. And then you have to get, the secrets for accessing those cloud services for like your database plumbed into your deployment. So there's a lot of like intertwined, collaboration that needs to go on. And then you need to layer on top of that, kind of the auto scaling behavior, ingress, the security groups, the health configs and all that kind of stuff. And so what we see in a lot of the folks that we work with in kind of medium and larger companies is that there's often like a platform ops team or an infrastructure ops team that's responsible for kind of putting together like the organizational best practices and security policies and kind of building out this internal cloud platform that the app teams can use to more efficiently deliver those apps. But if you're creating bespoke infrastructure configurations, oftentimes just getting this whole process working can take days or weeks, oftentimes just shy of like a whole month to get all the app config going into production in a stable way. So it can be a huge, time sink and definitely not as efficient as it could be. So, in addition for it just being difficult for devs to get the apps into prod and having these things glued together in the imperative pipelines, is that you're really gluing together multiple tools and they have multiple management models and multiple representations of state. And oftentimes these are inconsistent across the different environments. And so it becomes increasingly difficult to master the interactions and the failure modes across all these tools. And that typically results in, error-prone deployments and difficulty in just being able to understand what's going on. So it creates a lot of friction in the pipeline. On top of that, there's often no clear ownership in terms of the various aspects of the app config and the cloud services and all the interactions between them. And so when a change is made in one aspect of the configuration, it can often cause unintended consequences and override behavior in other aspects of the configuration. And oftentimes, these issues are only found at deploy time. And so hopefully most of the time this is caught like in the staging environment, where you just keep turning the crank over and over until you get a successful deploy, and then roll it out to prod. And most of the time that catches most of the issues there, but oftentimes not. So definitely some limitations with this approach. So what are we looking for in an app model? If you're just running on your local laptop, using Docker Compose is great. It's a self-contained app model. You can use in-cluster stateful services, and life is good. Then you need to get it into Kubernetes. So you can use Compose with a K as a tool to convert the Docker Compose into Kubernetes core resources. That's an option, but really you want to have kind of an authoritative desired state and kind of make your changes in Git to those resources. And so then when you go beyond, having in-cluster stateful services to cloud services, you'll bring in your IAC tools, your infrastructure as code tools, Terraform and CloudFormation and so forth. And that does give you more separation of concerns, but it doesn't give you a K8s native declarative management experience. And so sometimes, we'll see companies spinning up GUI portals for provisioning infrastructure. And that does, kind of as an alternative to using the infrastructure as code tools in the pipelines. And that does provide a separation of concerns, but it doesn't really give you something that you can automate very easily, and it doesn't give you that Kubernetes native experience. So what we've seen come onto the scene here in the last year or two are service operators here towards the center. And this includes, GCP config connector, AWS service operator, Azure service operator, Crossplane providers. And what these do is they bring in the individual cloud services as Kubernetes CRDs, and they're the low-level managed resources that provide a high-fidelity representation of that cloud service. So you can drop a Kubernetes CR, custom resource, which is just a YAML file for a database or a cache, and it'll go out and provision that for you. And some of the service operators do a good job of letting you just drop an entire config of, hey, if I want a secure database that's production ready and monitored and all these things, I might need, 5 or 10 or even 15 different resources. And so I want to kube control apply that entire directory of config. And so it does give me a Kubernetes native declarative experience, but the separation of concern is still pretty low level. So, if we kind of move up to the top, another option is just to say, I don't want to deal with infrastructure at all. Just give me a platform as a service, give me a PaaS, Heroku style, kind of experience. And most of these PaaSes are, built on Kubernetes these days, and some aren't. I mean, you have like Cloud Foundry, and they migrate over to Kubernetes, and you have OpenShift, and then some more modern ones that are kind of more container focused with Cloud Run or Fargate or Azure container instances. But at some point, the confines of the PaaS don't satisfy all your requirements, and so it does a really great job of providing like a highly opinionated way of building apps and a great developer experience for doing that. But when you run into one of those boundaries, PaaSes aren't typically as extensible. So that if you want to add, a new capability to the PaaS, it's kind of going outside of its boundaries, and it's difficult to get that extensibility to kind of get exactly the type of platform that meets your organizational needs. So what we see in a lot of kind of the medium to larger companies that we work with is, kind of a internal cloud platform team or a cloud platform or a platform ops team be created with the charter of, providing these organizational best practices, security policies, and a running platform that just makes it easier for app teams to use and then go and get that running out of the gate. And so wouldn't it be cool if you could, as a platform team, compose from the service operators all of your, kind of curated menu of infrastructure that took those, I want a secure database, and just made it available as a building block to an application. And that the app devs could take their container images and publish those so that those could be used as building blocks. And we had this team-centric app model that allowed us to compose together all of these building blocks, and then it would just go through from developer laptop into production in a much more frictionless way. So that's what we're after. And if we look at some of the desirable properties that you might be interested in when you're looking for an app model, it obviously has to model the entire production application. We want that Kubernetes-style declarative management so that it keeps trying on our behalf to kind of achieve that desired state. And ideally, that should be done with idiomatic Kubernetes. So when you have things like label selectors and things that you would expect to be present on a Kubernetes resource, and following the Kubernetes patterns, that's available in this app model. And we want a clean separation of concerns so that the different aspects of the application are in different resources, so that the team can make those changes without having unintended consequences and having one configuration change override the behavior in another. And ultimately, we really want extensibility via the Kubernetes API. We don't want a limiting pass abstraction that's too abstract and not extensible, or a GUI portal that doesn't allow us to extend it. We want something that says, hey, if I want to use a new technology in my platform and I want to make that available for use within my app model, I should be able to compose and use any Kubernetes CRD, any kind, in my app model definition. And ultimately, we want to get this streamlined path from dev laptop to production. So it probably goes without saying, but we want to be able to use the app model with Git as a source of truth. We want to be able to use existing tools like Helm Customize, Flux. And we want to be able to use our existing deployment workflows so we don't have to drop everything that we've done to date and replace it with the new way of doing it. So if we look at what a modern application looks like, and this is the simplest possible modern application with our PHP web app here and a Redis backend, but those are effectively two components of this simple app, and they have different aspects and characteristics in terms of, do I want auto scaling, manual scaling, for my ingress route through my API gateway? How do I want that configured? Which security group do I want to kind of control who has access to what and on what networks and so forth? And so that basically defines the app. And so if we were to separate those aspects into what I want to run and how I should run it, we basically get this separation of concerns. And so we have the components, the building blocks on the left-hand side, the what to run. And then we have the operational configurations on the right-hand side. And this can include, how I want to go and group and reason about things, or operational strategies for, how I want to upgrade or how I want to scale. So if we look at this in combination with, what we have with the open application model, there are 5 kinds or resource types. So there's a workload, which we talked about, which is basically what I want to run. There's a component, which is an instance of a workload that I can compose into an application. And then there are traits and scopes, which are operational behaviors that I can apply to a component. So I can apply a trait to a component that modifies the behavior and effectively overlays configuration onto that in a defined way. And then I have scopes that can basically group resources together. And I can use that for networking scopes or health scopes and these types of things. And I can put all of that into an app config, an application config, and then just deploy that. And so what we'll see is that, with our PHP app here, we have the PHP as a workloads container image. We have Redis, which is our, Acme Corp, secure, scalable Redis that we've defined that might have, a handful of resources bundled into it because we've composed those together using Crossplane, for example. And then we have, traits and scopes in our app config that are bound to those components that define the operational behavior of the application. And the great thing is that these are all Kubernetes API resources. And so I can, version control, I can use GitOps, I get all the benefits of, being able to use all the tooling that works with the Kubernetes API, and not just kube control or, customize, and kind of modifying those resources. But even things like the Terraform Kubernetes operator, right? I mean, I can use any existing tooling that I want since it's based around the Kubernetes API. And so when we look at the separation of concerns across, these different roles, the app dev can create their building blocks, the container images for their, web UI, their service, APIs. The platform ops team can create their infrastructure composite resource definitions. I want a secure Postgres, I want a scalable Redis. And then I'm going to go ahead and compose those so that they're easy to consume building blocks that an app ops person or role can compose into an application configuration by dropping components in there and then associating traits and scopes to those components. So I'm going to hand this off to Sudhanva, who's going to walk us through using Crossplane and Ohm to deploy a Kubernetes app with cloud services entirely from the Kubernetes API.
Thanks, Phil. So what I'm going to show is how we're going to deploy this microservice-based application that's backed by PostgreSQL to a Kubernetes cluster using Ohm and Crossplane. So we're going to use Crossplane to deal with all things infrastructure. So Crossplane is going to manage the connection to our backend Azure cloud provider. It's going to be responsible for exposing the infrastructure resources that are available to the application developers and operators. And then we're going to layer Ohm on top of Crossplane so that the developers and app ops people can just deal with the application constructs. And I'm going to try to do this all in a live demo. So I'm just going to share my screen and we're going to run through things. So first, I'm going to run through what it looks like from an infrastructure operator's perspective. So I've cheated a little bit and I've already got a Kubernetes cluster on my machine powered by Kind. And on it, I have installed Crossplane. And Crossplane is going to be the control plane that's going to manage all of my infrastructure for me. So if I do a Kubernetes get Crossplane, I can look at and see that I've configured the backend Azure provider already. Next, my goal is to expose the infrastructure definitions that I want my application operators and developers to use. Now, because I know the microservice application uses Postgres, I'm going to go ahead and create something called an infrastructure definition, which is the thing that acts as the schema for the PostgreSQL instance. So here, I'm defining the schema for what the PostgreSQL instance looks like and what needs to be declared when I'm creating Postgres. So to apply this, because it's a Kubernetes resource, I can apply this just like I would any other Kubernetes resource. So I go ahead and do kubectl apply, and it gets created. Next, the schema is created, but I still want to expose this to developers and operators. And that's where the infrastructure publication comes in. The infrastructure publication makes sure that the infrastructure definition I created is actually available to the operators and developers. And likewise, this is also something that I can just do a kubectl apply to. The third bit of infrastructure, and the part that I find the coolest and where Crossplane really kicks in, is something called a composition. A composition is the thing that takes different infrastructure components and puts them together into one unit. So in this case, because I'm using the Azure provider, I know that Azure has a few things that I need to declare in order for me to get Postgres. I need to create something called the resource group, the actual PostgreSQL server itself, and the Postgres firewall rules. Instead of dealing with all of these separately, I can create something called a composition, which puts all of these together and applies labels. So this is easily available to my developers and operators when they declare it as a requirement. So I'm going to go ahead and do the same thing, which is apply this particular composition. Now, at this point, this is available for operators and developers to use, and they can declare a PostgreSQL instance as a requirement in their apps, and Crossplane is going to go ahead and ensure the right things are provisioned in the backend provider, which in this case is Azure. The last step for the application for the infrastructure operators is to expose the necessary workload definitions and trait definitions. Now, these are Ohm concepts. In Ohm, a workload definition is something that the infrastructure operator can expose for app devs to actually run an instance of something. In this case, those are containerized workloads and a PostgreSQL instance. So the infrastructure operator is saying, hey, on this particular environment, you can run containers and you can run PostgreSQL instances. Traits in Ohm augment the way certain workloads run. And in this case, the only trait I'm exposing is something called as a manual scaler trait. And we'll go ahead and see what that does when we get to the actual components in Ohm. So this is the last step for the infrastructure operator, is making sure that the necessary workloads are actually exposed. Next, we're going to transition and look at what the application developer has to do. As Phil mentioned, the application developer is responsible for prescribing what needs to run. So because I'm running 5 microservices, I'm going to declare each of those as an Ohm component. Within those components, you'll notice that I have a kind here for the workload. So this is a kind PostgreSQL instance requirement, which tells Crossplane that in order to run this component, you need to go ahead and actually create something in Azure that is a PostgreSQL instance. If you look at all the other components that I'm creating, they're all of type containerized workload. There are 2 things that I want to call out here. One is in the component, I'm specifically calling out how much storage I need. And if I go back to the infrastructure definition, you'll notice that that's something that was required. The other thing I want to call out is there are certain parameters that the application developer exposes in a component. And these parameters are something the operator can take and override so that they can configure how certain things run. So in this case, you want to make sure that things like the database secret are something that you absolutely need so you can connect to the database, but the operator probably knows which secrets to use in various environments. So as a developer, you're still going to apply this particular spec to the cluster so that these components are available to actually create an application. Now at the start, I did a kget crossplane, which showed what Crossplane is managing. If you take a look at this command now, you'll see that there's a lot more things that Crossplane is looking after instead of just the provider. All of the infrastructure publication, the definition, and all of the Ohm constructs from trait definitions to components are things that Crossplane is actually managing. If I do a kget pods, you'll notice that there's still nothing running. Everything's declared, but nothing's actually running quite yet. To get things running, we shift over to the AppOps persona. These personas don't necessarily need to be different people, but they are separate tasks that are streamlined for each persona. So in the application configuration, I'm creating instances of each component, providing the necessary parameters that were exposed by the developer, and applying any traits that I want to do. So remember that the infrastructure operator exposed the manual scaler trait definition. That means that an operator can apply this to configure how many replicas each component's run in. In a staging environment, you might not care about the number of replicas, but in prod, you probably want to set it to something that is safe. So when I go ahead and apply this configuration, we should start seeing all of the pods spinning up on our kind cluster. So we're just going to put a watch on this. The data API microservice connects to backend Postgres, which in Azure takes some time to come up. So while that spins up, I'm just going to stop sharing my screen and run through the rest of the slides. This should take around 4 minutes, so we'll come back in 4 minutes for this. So I want to go ahead and talk about the Kubernetes app model and what the ecosystem looks like. So we've created a magic quadrant based on what Phil mentioned earlier, where the y-axis is really the separation of concerns, and the x is talking about how Kubernetes native the tools are. We have Docker Compose, which is a fantastic tool for entry-level developers and also just as a low barrier of entry into the container and Kubernetes ecosystem. Here, there's not much of a separation of concerns, but if you're coming into the Kubernetes ecosystem, Docker Compose is probably something you're going to use initially. Next, we have tools such as Terraform, CloudFormation, and ARM, which are all infrastructure as code tools. And here, you can describe your Kubernetes core resources, and it's a step towards having a separation of concerns. And it's not quite Kubernetes native yet, but it is declarative. If you go further down the x-axis, this is where you get the Kubernetes core resources and the service operators that Phil mentioned earlier. So here, everything is a core Kubernetes resource, whether it's stuff that the clouds are representing as Kubernetes CRDs or Kubernetes core resources themselves. The small problem with this is that there's no separation of concerns, so everything here is exposed for anybody. So this is where you level up into tools such as the Kubernetes or the Crossplane composition, which looks at combining a bunch of infrastructure together to create compositions. What Crossplane does with composition is gives an abstraction for platform ops people to interact with compositions instead of a bunch of infrastructure with various providers. When you layer Ohm on top of Crossplane, it creates a natural abstraction layer between infra ops, app ops, and app dev. I want to touch a little bit on where the community started and what's coming up next. So when Microsoft initially kickstarted this project, I think it was at the beginning of last year, we partnered with Alibaba Cloud to create the spec. And soon after, Upbound joined with its Crossplane folks to actually contribute to the specification. We've been very involved in the sig-app-delivery SIG, which is part of the CNCF, and Crossplane was recently submitted as a CNCF sandbox project. When Crossplane joined, we quickly recognized the powers of these two projects together, and we made Crossplane the Kubernetes implementation of Ohm. Ohm is definitely in its early stages, and one thing I want to call out is when Crossplane joined us, we actually changed the spec a large amount from what it was before they joined to what it was after. So there's still a long ways to go, and there's still a lot more contribution that we can take from people across the ecosystem, and really just a call to action to come join the community and help us improve app development in the ecosystem. I want to quickly check on the demo and put a wrap on it before I move on with the slides. If I do a Kubernetes get pods now, you'll see that the data service is connected. All of the demos, and if I go to the Azure portal and I do a refresh, you'll see that Crossplane has now provisioned a PostgreSQL instance in Azure for me. The demo steps that I followed were right from the Crossplane docs, so it's nothing magical. I'm going to do a port forward to make sure that things are listening. Sorry. Already had opened it from an earlier demo. So now if I hit the localhost 8080, you'll see that the service comes up. I can just do a refresh on the flights data to see what kind of flights are running across the states and the world right now. I think this is the service that takes the longest to pull. I should have done weathers for one that was quicker. Switch to weathers, actually. There we go. So you can take a look at the weather across the states and the world. It's fairly hot across the US. So that just puts a wrap on the demo. So what we saw there was how you can compose a microservice-based application using Crossplane to abstract the infrastructure concepts away from the platform team, and then Ohm to create that division between app ops and app devs. Here are some links to get involved with us. Ohm.dev is a great link that has the rest of the links, like the community sessions, our email list, our Slack channels. Crossplane has its own community with its own Slack. It has its GitHub page. And the last thing I want to call out is that there are two other talks that are happening at KubeCon Europe or KubeCon Virtual. I don't know what to call it anymore. One of them is a panel that's being ran by the folks who created Helm and some of the folks who created a lot of the contributions to the Kubernetes ecosystem. And then we also have another one by Upbound and Alibaba talking about Ohm and Crossplane there as well, and its partnership with Alibaba. And with that, I want to kick off the Q&A session, and Phil and I are happy to answer any questions you folks have on either Ohm, Crossplane, the partnership, or anything around apps across the ecosystem. Thanks for the talk, and look forward to questions.
Great, thanks, Sudhanva. So we do have a ton of questions on the on the talk here. So the first one is, for services to leverage the operator, do they need to host services in Kubernetes? And so Crossplane is from the creators of Rook. And so, we do support like in-cluster, but we mainly focus on managed services or cloud services that you want to provision from AWS or Azure or Alibaba, GCP. And so we have providers for all of those, and there's more on the way. And that basically enables you to provision those managed services or those cloud services from the Kubernetes API. And so you can just drop in, like a simple YAML, declarative YAML file, and then provision alongside your applications, whatever infrastructure your applications need. And then that will go and through Crossplane, reach out to your cloud provider and provision those, and then basically bring the secrets down and then allow you to consume those services from your Kubernetes applications. So great question there. There was another one about, saw that Crossplane is a controller operator project. So have you thought about providing it via Operator Hub? And yes, so if you go to blog.crossplane.io, it's the third blog down, and we talk about how Crossplane has been published to Operator Hub already, and there's an integration with OpenShift there that makes some of the managed services available so that you can use Crossplane for provisioning your managed services from your cloud provider. And so I definitely recommend checking that out for more detail. But when I think about Crossplane, there's really like three layers. There's the base layer that provides the primitives. Those are the Crossplane providers. And then there's Crossplane composition, which sits on top, which allows you to compose without writing any code, all of those primitives into your own infrastructure abstractions, your own platform APIs. And then you can publish those as open application model workloads that can then be consumed and composed into an OM application. And this is all designed to be layered. And you can mix and match whatever you want. So you can just use the providers at the base layer, you can use composition, you can use OM by itself, or you can use all of them in combination with each other. So yeah, good question. How would you version the component templates that developers can use and have to fill in? They need to be updated regularly. That's what's the benefit over using CDK to define applications from some pro templates functions. Yeah, so great question about CDK. And there's also kind of an offshoot called CDK8s. And so we're actually working with Alad from CDK8s to look at providing more than just like the YAML-based composition that we support today, but actually being able to run other types of compositions from behind the Kubernetes API line. And so that'll allow you to use like a CDK8s program that would compose your infrastructure resources and then basically have that output the Kubernetes resources directly there that would be made up of Crossplane primitives. And so then you can basically use those. And then the really beautiful thing about being behind the Kubernetes APIs is that if one person writes a great composition in CDK8s and then publishes that you can then compose it using the standard YAML composition or other tooling. And so definitely, having this automation run behind the Kubernetes API line makes it open to the entire Kubernetes ecosystem. And that's something that's fairly unique to how Crossplane approaches the problem. And then also, if you go to the blog.crossplane.io and you go to the most recent blog post about v0.12, that'll run you through Crossplane composition, the primitives, the additional support for AWS services that we added, a whole bunch more great kind of CRD docs there from Hashdan, and a lot of great info there. When will Crossplane OM be ready for production? Both Terraform and Crossplane are at v0.12, but in terms of functionality, transformations and ecosystem cloud providers, the difference is huge. Yeah, so this is a great question, one we get a lot. There are some folks that are starting to use Crossplane in production now. And we're rapidly going towards 1.0, and so we'd like to get a couple more, production deployments under the belt before we call it 1.0. But we're basically moving from V1 Alpha 1 to V1 Beta 1 for composition. So that's basically ready for use now, kind of in an evaluative mode, and then in the next month or so, we're basically going to get that to V1 Beta 1, and so. For OM, that's similarly progressing. And so definitely by end of the year, I'm expecting to be 1.0, but potentially sooner. So yeah, that's kind of where we're at with that. And definitely encourage everybody to join Crossplane Slack. So it's just, and there's the Ohm channel in Crossplane Slack that if you have questions about Ohm, folks from Microsoft and Alibaba are there, along with the folks from Upbound. Yeah, definitely if you have additional questions about specific things or like when support is going to be added in for like scopes for networking and health scopes and stuff like that on Ohm, you can definitely drop in there. Let's go ahead.
Responded to the questions on the chat. I think there's one from Vasuki around a really good question actually around how operators are different from developers in this case, but the industry is moving towards these two folks being the same persona. So in such scenario, how does this help? I did respond to the question in the chat, so check that out because we only have like 30 seconds. But super quick, I think Ohm doesn't necessarily state that these two personas need to be different. They could be the same person, just the tasks are different and kind of clearly delineated so they can focus on the right things. And also these two technologies kind of set up the platform for, services in the cloud or third party where the infrastructure is hidden. And at that point, you're only dealing with the application construct. So that's how it's supposed to help developers and kind of this whole DevOps persona that's being created.
Yeah, exactly.
I think that wraps it up actually. We're
over time. Over time. Okay, great. Thanks. Well, thanks for joining, and we'll see you all online.